Namaskar. Welcome to Prakash on Basics. I am Prakash Zog. Our major area has been light, but from today for a few weeks, I'll be talking on uh, a major aspect known as laser. Please realize that laser is an invention, not a discovery. Laser is a technological marvel arising out of the intelligence and insight of humans, all their scientific acumen, as we can talk of. It is something that nature has not been able to develop on Earth, um, in spite of the 4.5 billion years of Earth's existence. Nothing of this perfection in all these years. Just imagine a steel hull ship, uh, thickness of steel around minimum 2 to 4 inches. Um, they have to be these sheets have to be cut and they have to be welded together. Previously they used to take months together. Today, using a CO2 laser, the job of cutting a steel plate can be done in minutes. Welding can be done in a couple of hours. All this because of a CO2 laser invented by um, one Dr. Kumar Patel, an Indian, long back. I'll go into that detail sometime later. Think of a surgery when there is a cut taken. It's so obvious that there will be all blood spilling around. But with new techniques, what you have now is bloodless surgery. And that's again using a laser. So, what is all this laser? Please realize that laser is an abbreviation. The abbreviation itself tells us what the laser is: light amplification by stimulated emission of radiation. LASER. That's what laser is. We'll first look into what's the science, basic science behind it, the historical background, and the working logic of what a laser is. These lasers have introduced a lot of new terms in the branch of science to a large extent. Stimulated emission, population inversion, pumping, lacing action, and so forth. I'll be discussing all these as and when required in our future lectures. Usually, uh, we talked of long back how light is produced. Light is given out when in one basic process known as spontaneous emission. During electrons that get excited can't remain there and come down. And in the process, they give out light. The light is given out in all random directions. It has a number of wavelengths, a spread of wavelengths basically, and they are all unmatched waves. This is more like the end of a cricket match and all the people coming out randomly through a number of gates um, at the from the stadium. That's how spontaneous emission takes place. Then there is a second pattern. It is known as stimulated emission. Two major scientists, Max Planck and Albert Einstein, had talked and mentioned of this stimulated emission in their early discussions in theory. Obviously, stimulated emission requires a stimulus. And if you can provide the stimulus, things are going to be different. In stimulated emission, uh, the light comes out, but it comes out in a very specific manner. This is like not like the people crowd coming out, but it's like a troop that we see marching on in a parade. uh, 26th January parade that we see in New Delhi. A whole bunch of soldiers uh, marching together. All their motion is synchronized, perfectly matched to each other, very well coordinated, fixed direction, and you can feel the strength and the intensity of everything that is around. By using modified concepts of oscillators and amplifiers, suitably combining them together with aspects of enhancing the number of light particles that come out, it is possible to increase the properties of light to unprecedented levels. This amplification takes place in a particular medium, in a certain gap, which is typically referred to as a resonating cavity. And this produces what is known as coherent radiation. That's a technical aspect. I'll go into the meanings of some of these as we go further. This then is the science behind the working of what lasers are. But it didn't start as lasers. Lasers are a logical modification of another device. Uh, it is an extension of an earlier device known as the maser, microwave amplification of stimulated emission of radiation. So instead of light, this is microwaves. The science had been developed to some extent. In 1953, Charles Towns of he produced using ammonia gas a particular maser, and that started off the whole process. Work was being done by not only him in the US but by others in other countries also. And later on, the theory behind it, the understanding of the instrument that was developed, was all under a branch known as quantum electronics. And in 1964, uh, him and Prokhorov and Basov, these three people got a Nobel Prize for their great achievement in developing the theory behind the masers. Masers are microwaves, but it's not restricted only to microwaves. It also includes radio waves. Uh, and they are used still and very important. Um, Atomic clocks that measure time extremely precisely. A billionth of a second is the amount of error that can take place. Those are designed using masers. Radio telescopes utilize masers. Spacecraft communication takes place because of masers. But they have a certain range of wavelengths. Usually, their frequencies are less than 3 gigahertz, and then they are referred to commonly as masers. It is the development of the masers that led into applying it to the optical part of radiation. So, what we came up with is the laser, which is nothing but an optical maser. 16th of May 1960, in the Hughes Research Lab in California, uh, Dr. Theodore Myman produced the first laser beam using an artificial rod of ruby. There are a lot of parts associated with this machine itself. All that we will talk of later, not now. Realize that this is a device, and what it produces is a laser beam. So it's a laser device that he developed. It's a light oscillator and amplifier put together in a special manner. It amplifies light by stimulated emission. So it's basically an optical amplifier. And what is used is an artificial ruby. Ruby is aluminum oxide mixed with chromium oxide, Al2O3 plus Cr2O3. Uh, Out of it, it is the chromium ions that are the ones that are used to produce laser beams. The chromium ions, that typical pink color that you see in ruby, something like this, is because of a very small percentage of chromium that is put in aluminium oxide, about 0.5%. That is, zero point 0.5 will reduce down to 1/200th part of the net amount of Al2O3 that makes it into a ruby. Um, the whole thing is a solid rod, and ruby is an extremely hard material. So this type of a laser that was developed was the first one and was known as the solid state laser because of the nature of the material that was being used. If you change the medium, then you can produce lasers of different types. Uh, and a number of attempts were made after this. In 1960 came what are known as the gas lasers, first by an Iranian, and then that was the helium neon uh, laser, which became very popular and was used there. And then came the most important one, which is the CO2 laser, as I said, um, developed by an Indian, but in the US. Uh, then they tried liquids. So to liquids, they added what are known as dyes. And a dye is a coloring agent. Go into details afterwards. Uh, that produces what is typically referred to as a dye laser. And its biggest advantage is that its frequency, naturally color also, can be changed in the process. After that came, we had solids, liquids, gases. So then came semiconductors. And so semiconductors were utilized to produce lasers also. Nowadays, the most common type is referred to as the YAG laser. Uh, that's one of the most common types. And they can produce a beam of light continuously. So it's known as a continuous laser, or it's a pulsed laser. So what is the laser? Remember, it is still light. So it follows all the basic properties of light. Only the properties have been enhanced far beyond their normal. It is an extremely intense, bright beam of light that comes out of the laser device. It is so intense that it illuminates all the air particles or the dust particles in its path. And so you can actually see the pencil of light as it goes through. Uh, it has only one color. That's typically monochromatic. But lasers of different colors can be produced by using different laser devices like the ones that I told you just now. Actually, some of the lasers are beyond the range of what humans can see. That means our visual threshold. And they could be in the infrared region, they could be in the ultraviolet region, they can also be in X-rays, they can also be produced in gamma rays. And each of them have their own uh, type of applications. But generally, when we talk of lasers, the frequency has to be more than 300 gigahertz. Giga is 10 raised to 9. So you can imagine the frequency, the range of frequency that can produce lasers. These lasers are uh, not just useful, but they can also be extremely harmful and dangerous. Never look into a beam directly of a laser pointer. If it falls on your retina, it's going to damage your retina permanently. But then uh, the same laser can be also used to create to improve a lot of eye defects and correct defects in the human eye, as we talked of long back. That's because a variety of properties uh, have been controlled very precisely by human ingenuity, and different types of lasers have been developed to suit our requirements. How they are put to use is something that we need to understand. We also need to understand how lasers themselves are produced. We'll go into all this as we move further. We need to know, understand their properties also in general. If you have liked whatever I have talked of, um, please tell your friends about it. Like and subscribe to this channel. Uh, Try and catch up information regarding lasers and look around you, see how laser pointers are used, and read up, if possible, of what lasers can be used for. We are going to come and try and understand the basics because that's very interesting, not very difficult, not very complicated. Till we meet again to understand all this part. Prakash on Basics saying Namaskar.